Hello, and welcome to another session from Great Learning on AI and matters relating to AI. What we'll be talking about today is how to make an AI product. Now, I want to make one thing very clear before we start. We will not today be talking about software and software engineering. Today's session is more about the business side of what AI products are. What does it take to make AI come alive? What does it take to make business propositions around AI? And how does that fit into the specific technologies that we talk about in our programs? We'll talk about new ideas and new markets and how that links to all the exciting technologies that we have spoken about in forums such as this from people such as me. Before we start, I want to review a little bit about what we mean by AI. So what we mean by AI, artificial intelligence, is something very specific. And it has to do with two ideas in modern technology. In brief, these are big data and deep learning. Big data, and you've heard this term many times, concerns itself with data that comes with high volume, that means lots of it, that comes very quickly, maybe over digital media, usually over the internet or any such networks. Lots of kinds of data, which we'll talk about soon. And very importantly, considerations of making sure that this data is correct, valid, safe, proper, secure, etc. This data can come from people, and this data can come from devices. Now, I talked about variety, and the variety of data that modern technology deals with involves not just numbers, but things like language and text, and things like images, video, etc. This is what is leading to what we are calling AI today. This confluence of data and various forms around data, like language and vision, that relate to humans, people like you and me, how we see, how we speak. Connecting that to high-end computing resources like GPUs and multiprocessing supercomputers. So what we mean by artificial intelligence is data-driven technologies that leverage big data to provide value of what kind? Specifically, we'll talk of the business kind. That doesn't mean that other areas of AI, for example, for national welfare, for social well-being, etc., are not relevant. Not at all. But for today, we're going to talk about how we can make AI a value proposition for business. And again, in review mode, let me briefly connect the older world with the newer world. What I mean by the older world is the world of, shall we say, business intelligence. Intelligence that data gives to business. And this could be in things where data has built solutions already and that stay in place for some time, what we had called static solutions. For example, models that score customers, that gives numbers, some value propositions to customers based on their data. Will they churn? Will my customers leave me? Will they default? Will they buy? These models can, of course, evolve in time. When they evolve, they become dynamic models. And this is becoming very interesting as a value proposition. In other words, these become new services even, new ways of solving old problems, perhaps, new ways in which models get updated. For example, think about COVID mutations, new forms of the virus that are emerging that need to be fitted into our ways of understanding how this disease might progress and impact business, or new ways of committing fraud. Please don't commit fraud, but if fraud is committed on you, how do you adapt a system to different kinds of fraud? Now, remember I talked about data. And so these new kinds of data leading to artificial intelligence using deep learning can also be used in the same way, but they involve different kinds of information. For example, text information on social media feedback. Do people like my brand? So much of business today and business opportunities, entrepreneurial opportunities, are leveraging human opinion. And human opinion is expressed through language. So if we can understand what people are saying in an automated way, that's a huge business opportunity. Possibly important products as well. And we can see those products every time we log on to our networks. And of course, if these products become dynamic, by that what I mean is if they have the ability to adapt, to learn. For example, new kinds of manufacturing technologies, reprogrammable robots that allow one to do different kinds of faster manufacturing, Industry 4.0 as it is called. So going from the world of dashboards to the world of robots, artificial intelligence is leading to wonderful opportunities for business leaders to convert things to value. This is what programs like AI for Leaders in Great Learning do. They talk about the value proposition of AI and how do we create that value story. Now, you might be wondering very correctly that isn't all this complicated? Isn't all this a pure technology story? And if so, do I now need to invest in a large number of technologists in ivory castles or ivory towers building code? Is it a very high-tech world? And if so, as a business person or as someone who's in sales or in support or in marketing or in finance or in HR, is this my world? Some things are making it quite possible that this may be your world. For example, the cloud. What is the cloud? The cloud is a place where code lives and lives in a way that allows you to access it and play with it without necessarily having it on your computer and doing things within your premises. But the cloud is also something else. The cloud is a service. And we often hear words like software as a service. What is that doing? What that is doing, it is allowing for the development of various kinds of software away from the computing environment that is within a company. That means the creation of infrastructure is reduced to a matter of payment, a matter of subscription to the service. A couple of examples that we use in our programs, AI for Leaders programs and other programs. The bottom example is from Microsoft Azure's Machine Learning Studio. And what you see here is a way to build a model, not necessarily by coding, but by allowing various pieces of code to run with simple drag and drop operations. Now you might say, but that isn't software, that isn't a product. And you're right. But in order to build a product, engineers have to do a lot of prototyping, a lot of testing. Does it work? Will this model work? Will logistic regression work? Do I need a decision tree? All these kinds of questions AI engineers and machine learning scientists would ask. The leader may concern himself or herself with such things. Or they may say, let me see what you are doing and quickly experiment on a variety of things. You may ask them to experiment. You may experiment yourself. This kind of real-time experimentation without the need to invest in large, shall we say, skill bases that are deeply technical is what is making AI such a wonderful opportunity as well. So, number one, the ability to build models, test them out without necessarily getting deep into the data or deep into modifications of the code. Of course, if you want to do that, you are very welcome. Nothing stops you or your teams from doing it the old-fashioned hacking way. And an engineer may absolutely love it. All I'm saying, and all we say in the program, is that there are alternatives. Another such cloud environment I'd like to mention is from AWS, Amazon Web Services. And what you see here is Amazon Comprehend, which deals with text. You can't see very clearly here, but that's not the point. You can certainly go to the AWS website or to the Microsoft website for Azure and see for yourself. I certainly encourage you to do that. But these kinds of text analytics engines would say, give me the text and I will analyze it for you. I will, for example, run a sentiment analysis for you. Which means that if there is a mechanism in which text gets loaded into the cloud, let's say, for example, feedback, email feedback, or social media feedback gets systematically loaded, and the sentiments are continuously analyzed, the results of such a sentiment analysis can be made available to the company and can be made available to product engineers to build technologies on. So what that means is the definition of an AI product, the building of an AI product now has reduced to adding, shall we say, human interface layers to things that are available on the cloud. This is extraordinarily powerful because what it means is that even smaller companies can make AI products, or large companies can make AI products that work for specific tasks that they may have. This can be entrepreneurship. This can be intrapreneurship. And in the AI for Leaders programs and other such programs like it, both kinds of learners join and certainly gain benefit. So what are the kinds of things that might emerge from what I just described? The various kinds of data, the various kinds of business problems, and the various kinds of deployment environments. What can emerge? In our programs, in the AI for Leaders programs, a capstone project is done by groups of learners What this means is we encourage those attending the program to go out and define what they feel is a good product or a solution. Apply what they learn within the context of this product or solution. And then put on business layers on top of it, which we'll talk a little bit more about soon. And some wonderful projects come out at the end. Here is an example. And I call this a project that lived because this is a project that has actually seen the real world. In other words, it's being used, it's being sold, it's being produced, what have you. And it talks about many of the things that we mentioned. There's an abbreviation here which sort of briefly describes what this product is trying to do, FHIR, Fast Healthcare Interoperability Resources. So FHIR for short. What FHIR does is it sets up data standards and APIs, application programming interfaces, for healthcare organizations so that their data can be systematically organized to a standard and on which algorithms and various data operations can now be done. So think about it. If such a standard and set of APIs, data standard and set of APIs exists, then what you can do is you can take various kinds of data, you can convert it, and then do all this kind of data magic that I was talking about. You can talk about, for example, text, maybe what doctors say. You can talk about images, maybe medical scans. And you can do various kinds of analytics and value propositions. And then use the same standard maybe to come back to the real world and show that value. To whom? To patients, through healthcare providers, and so generate possibly a variety of revenue streams. Now, this left-hand side is where the technology is, and the right-hand side is where the business is. And so, therefore, making such a product implies what? Number one, an understanding of what is required from a customer or user perspective, the translation of that into a technology stack, and the input of data and programs into that stack. While we do not teach all of this in the AI for Leaders program, what we do is enable the thinking that makes such a thing possible. It's a relatively short program running over the span of weeks and not over the span of, shall we say, months or years. And therefore, the details are left for individual attendees and learners to dive deep into. And the details vary. Some learners love the technology and find out much more about it, much more maybe than the Azure or the AWS that I spoke of. Some learners love learning about their domain, their businesses, and how does it work within their own industry, be it healthcare, be it general manufacturing, be it finance, banking, etc. And some learners take the opportunity to dive into new opportunities, new value propositions for new customers and new potential users. This unification is what AI for Leaders accomplishes within the 4 months of the program. And a good 1 month is spent on putting it together in projects such as this. And of course, before it is all the technology around cloud and the various algorithms that go into doing this. But really, the learning for leaders is that AI is a business opportunity. And what is the leadership story around that opportunity. Now, what have been our learnings? What have been the things that our learners have found out and we have found out? So let me spend the rest of the presentation taking a more business angle to this. You've heard a lot about technology from me and from others in this talk and before, but I want to change my hat for a while. And I want to think a little bit about value propositions. And you can ignore what is in this slide, and it is a standard slide covering what Porter called the 5 forces of what a business is. And it talks about competition. It talks about buyers and who will buy. It talks about vendors and suppliers. It talks about new companies and new technologies coming in. It talks about replacements. What can replace you? And the whole premise behind this is a holistic view to saying, what does it need to compete? And this idea of competition in this multidimensional way is what our learners need to experience within the program and add technology to it. So what does that mean from a practical perspective? It means think about competitors. Who are the likely competitors? It thinks about what are the relevant price points that a consumer can buy your product at. Who will you get technology from? For example, who will give you the data? Because as we had just discussed, without the data, this kind of AI isn't necessarily going anywhere. Then, what are you replacing? Who is replacing you? AI has an interesting side to it that you may have seen in the media. It is designed almost by intent to replace humans. You may have read that. It's half true. Some of it certainly makes healthcare more comfortable. For example, letting doctors treat patients instead of dealing with paperwork. Some of it makes manufacturing easier. Tricky, painful work in the factory is replaced by robots who don't feel pain and can be programmed to deal with trickery. Certainly, AI is that, a replacement of humanity. But there are many applications in which it is doing nothing of the sort. It is providing value of a very different kind. As we said, of being able to extract, for example, information from text and from images, of being able to process sensor data into standards so that it can conform to rules that other programs can use. So this world of AI, so to speak, is generating a variety of opportunities. And it is enhancing what a standard business model might look like. So the strategy part of this is certainly partly standard. Porter's 5 forces are not new. They've been around for 20 plus years in active use. However, the execution of it has interesting wrinkles, some of which have to do with the fact that the essential deployment of an AI product is a software. So some of it is about software, and some of it is about how we consume technology. So I was thinking about how to present that. And so let me tell it in a way that makes sense to me and to many others, in the sense of three circles. And these three circles address what AI products are supposed to be like. The top circle I'm going to call the good product. This is a good product, which means it's high quality. It works. For example, as software, it is scalable. It doesn't break down. Data security, all that, all of these are taken care of. With in-demand features, the features are correct. If it does sentiment analysis, it does good sentiment analysis. If it does image compression, it does good image compression. And this circle is about quality and features. The second circle, the circle on the bottom, is about speed to market. It's about saying that, can I build a product that can get to its user quickly? Now, this is especially important if you are dealing with a technology that is fast moving. And believe me, AI is one of the fastest moving technologies out there. New algorithms, new procedures, new applications are being uploaded into cloud servers as I speak. And so, therefore, being late in this game often means not being useful in the marketplace at all. Because maybe your technology has outlived its use and something better has come along. The next social media engine, the next search engine, the next Industry 4.0 implementation. So therefore, being quick to market is an important aspect. The third on the right is the value to the customer. Now, value could be something obvious, like, for example, cost, in which case value translates to saying, shall we say, cheap. Something is valuable as a product because it is simply affordable and is cheap. But value is more than that. Value is a collective proposition to the consumer, which includes, in particular, what I pay for compared to what I get. Now, for any product, of course, value becomes important. But for products based on data and software and machine learning and AI, value becomes particularly important because it's often a very confused proposition. The value may be in the data that you own and you can provide. The value may be in the labor that you save and replace. The value may be in the licensing fee that you pay by the way the software is being provided. There are so many ways in which this value can be stated. So these are in some way the three big circles. And there are different products that we have seen our learners and that are out there that are good in different ways. A purely good product is a high quality product with all the features, but it takes time and money and resources to build. A purely quick product is a prototype. But to build a quick prototype, you may need the best people. People who can work quickly and correctly. And of course, a pure value proposition is a product with the unbeatable price. In other words, it's focused on making sure that it gets the most value-based product out there. That's what it cares about. As you can imagine, a good product has many of these characteristics, or maybe is very good at one of them. And our learners and many other entrepreneurs have figured out whether they want to be on the sides or whether they want to slowly move in the middle. Because, for example, if the product is not good, even if it is fast and cheap, if somebody asks, does it do what I want? And the answer is a no, then however fast and however cheap it is, however quickly you can make it, it doesn't do what is required. Similarly, if you have a product that is high quality and is affordable, but takes too much time to build, then again, this is not going to be valued by the intended user. Doctors are often asked, why do you spend so much time and effort going after certain diseases like cancer? And they say, go talk to a dying patient and ask, when would you like this cure? Similarly, if you have a product that is quick, goes out, but at a price point that no one can afford, a technology that works maybe for the richest markets and not for many of the markets that, for example, in our countries or villages and many other areas where we really want to make the value proposition clear. So there are consequences to be paid when we don't consider all these three circles. And what we have seen our learners do is that they have understood what high quality is based on the technology. They've understood what it means in order to do it fairly quickly because of the advantages of things like cloud, etc. And related to the value propositions that they see in their own industries. As they go out, for example, to sell, a salesman will always want the best quality at the lowest price. And many of our learners come from an environment where that has to be made clear for some of these newer products. So therefore, what our products do or what our projects do is try to make something like this work. And so, for example, if I build a product such as this fire product, then to make it good means to make sure that various kinds of data is actually faithfully converted into the standards and that there is no corruption associated with doing that. Is that possible? And do we think that the project has accomplished that? To make it fast means that are there simple enough models that are already in existence for dealing with things like medical reports and scans and whatever hospitals would require processed through this product? Do enough product technologies already exist to do this adequately? And is it a matter of simply implementing, therefore minimize the new things that need to be done? And of course, the value proposition that goes behind it, which is the story that says that who will pay for this? Will a patient pay for it? Will it go through an insurance process? Is it attached to another service that the hospital may already have through the provider? How do I generate the value? How do I create the interfaces and the apps that will tell the user this is really good? You can do so much with it, get so much information on what is going on with you or in your clinic or in your hospital. And that value proposition is something that you may be willing to pay for. Together with even old age structures like dashboards and business intelligence, which I was sort of so dismissive of earlier in my presentation. I'll give you that as well. So this journey from high technology to sensible implementation to business value is what we hope our projects do. And what we hope leaders that we will create from the AI for Leaders program will learn in addition to their own natural expertise and interests. It is 3 steps and converted to many more steps by many others. And we are excited by the program and other programs around it within the Great Learning environment that address different parts of the story, the AI ML story, the DSB or data science and business analytics story, the design thinking story, the management story, the digital marketing story. They all fit in. And they all contribute to a leadership story. And in that leadership story for business success, AI plays a role. And that is what the AI for Leaders program is about. So I'm going to stop here and see if there are any questions that you might have, any discussion points that you might want to engage in, and then take it from there. There's so much more to say if there's time and occasion to do that, but this is your session as much as it is mine. So let's take a short pause now while we sort of collect the questions that are available and discussion points that may have raised, and see if we can talk around it a little bit. In the meanwhile, please do keep questions and comments coming in the forum that you're attending this session in. It'll make things much more interesting. We'll get to know what you are interested in. Maybe you'll make a new acquaintance, a new friend, and maybe you'll get a new idea. Let me address a few of the questions that are coming in. So Vinayak asks, how is quantum computing playing a role in AI? So quantum computing is the idea that says that instead of my circuit being composed of zeros and ones, let me imagine a circuit in which can be either a 0 or a 1 or maybe both. The way quantum physics works, the electron is here or here and here with a certain probability. What this does, the ability to build qubits instead of bits does, is that it speeds up computing enormously. Now, this has many implications. One common implication of this is that security becomes interesting. So, for example, a lot of security now consists of computing. Cryptography now consists of not being able to factorize large numbers. And this can be made a lot easier from using quantum computing technologies. That means the whole security nature of computing will need to change. That's a defensive story. Now, what is the offensive or the nice story, the attacking story? Things can be done faster. For example, weather forecasting, things that take traditionally a lot more time, things that we use supercomputers for, can now be done on much smaller machines. So things become quicker, faster, easier. But we're a long way from being able to get working quantum computers now. But if you want to think of what quantum computers can do, just think of something that can calculate much faster. Calculate much faster. Computers store data and computers calculate. Quantum computing is changing the game for speed of calculation. Think of what that means. Aishwarya asks, facing difficulties in finding a US client for an AI-powered chatbot. This is a question of how do we demo things. And one of the things that even our learners are struggling with, and all of us struggle with, is the tapping of the market. So while obviously I do not have the answers to that, my own entrepreneurial experience is limited and more in the healthcare space. But it is true that what you might want to do is come up with interesting ways in which your product can be demoed, or maybe not demoed at all, maybe created as an app that can live in a cloud environment somewhere and can be downloaded and can be run offline, so to speak, maybe a simplified version, and then look for feedback. We are trained in the demo world. The cloud takes you far away from demo. It allows people to make their own demos, and very often people want that. Anirudh asks, what are the prerequisites to start AI learning without any high-level coding or no knowledge at all? No knowledge at all is difficult, as I just said. You need to know or have some passion about technology or domain or software, etc. However, the other part of your question, high-level coding, by high level, what I mean is not necessarily a high-level language, but sophisticated coding, shall we say. As I had explained, in the context of, say, cloud, the level of technology needed to do things within, say, an AWS service or within, say, Microsoft Azure ML Studio, that is much lower than the ability required in order to program or code in the conventional sense. And this is changing the game substantially. So I would suggest go to one of these services and try things out, run it. Put a piece of text inside Amazon Comprehend, go to Azure and input an Excel data sheet and follow a demo and see what happens. Without writing a line of code, a reasonable amount can be done. And then, of course, it's your initiative on how you go further. But AI really is democratizing in certain ways. Rohit asks, how does business work out interdependencies across layers and deployable AI models? So in other words, how do we figure out how the different parts of things connect? So as an example, here, there is a data connection that needs to happen, sort of data to, shall we say, cloud. You can see the cloud described here, which has to be compatible with the standard. And then that has to be ported over into an app. Now, this requires obviously a certain amount of fairly sophisticated software engineering. But we have discovered that something interesting is happening. This particular platform nature of doing things is something that many companies, Google and many other companies, is beginning to provide. To say that if you want to develop a stack on this is something that you can use to do this, which is making lots of little AI projects quite possible. If you see, for example, AI projects that school students are building, they are using these development stacks. These are not full service stacks. These are very light stacks, and they're often developed for kids, for students. MIT Media Lab, for example, has invested a fair amount of time and money in thinking about how this can be done. So I would say, take a look at some of those things, think like a kid in this particular case, and see how things can be worked out. I have an 8-year-old who I'm pretty sure is going to start doing things that I have no idea what to do with. Pulkesh asks, is it possible that AI helps to improve website development? Developing a website itself, certainly, with chatbots and things like that. Although people often feel that that is an intrusion, that I don't want to talk to you. I want to see your information. Why do you want to talk to me? Let's not talk. Let's just, let me do my website. But if you're talking about development, developing the website itself, yes, but it's not an area that I am very well aware of. But there are ways in which software development itself is becoming much cleverer. And the older development SDLC lifecycle that would be needed for, say, full stack development, as I was saying, is no longer that valid. And Red Hat and many other organizations have spent time in making the development process better. But I think I'll defer to that question. But do investigate what many of these development platforms are doing in order to do, for example, improving code, automating certain testing tasks, and things of that sort. Abhishek is a little scared. If all things are automated, then there is no human, very less required, very less people required. That is true. And people certainly are worried, right? People are worried. For example, at some point, will you need me, right? A robot, presumably programmed, can give this talk, maybe better than me and more interesting than me. It will certainly can be made to look better than me. So yes, but the premise is that we will be, from a human perspective, that we will be able to do things that we like a lot more. There'll be more leisure. There'll be more opportunity to follow what it is that we like. The fear is not in making people redundant. The fear is in some way in the economics of it. A good AI project, a really good AI project, or a good product, shall I say, maybe get 10 million customers employing only 10 people. Now that from an employment perspective may be a little worrisome, that large markets get opened up with very few employees. But there are interesting new opportunities that come up here as well. Let me give an example. One of the things that is taught in AI is something called supervised learning. So for example, in the applications that I gave here, for example, in say scoring models, someone has to input that data and say whether this person actually defaulted or not. Or someone has to tag shall we say, a video feed and say this is where an intruder came in. In other words, supervised data needs human intervention to create a useful data set. And that's going to take a certain amount of time to still go away. And it is a bottleneck now, but as I said, interesting things are coming up. I don't know what the world of IT employment will look like in a full age of AI, but I wouldn't be fully worried. But you are right that, yes, certain kinds of skilling may be required. Will FHI FIRE be integrated across healthcare, insurance, and hospitals and research labs? We don't know. Right, HL7 and many other organizations that are pushing it. It certainly seems to be winning in many cases. This is not just a matter of technology, but also adoption. There are also other considerations of sovereignty and data protection that need to play. And so therefore, it's certainly a hopeful case. In certain cases in healthcare, this kind of standardization has worked, like for example, DICOM in images or PACS systems in hospitals. Whether FIRE will become something like that, time will tell. But certainly it's a contender and is getting a lot of champions, certainly in its newest incarnations. Ashutosh asks, business strategy or a failed product by a successful organization who have different successful products will market? Yes, so if I interpret that question slightly differently, a successful company has the ability to absorb failed products. So what that means is that a successful company has the necessary cash to be able to invest in high-risk products. And often a small company will not be able to do that. And so this is an entrepreneurial risk that many societies are trying to fix. There are lots and lots of AI support infrastructures, including in India, including from our government, many other proposals out there from Niti Aayog and MeitY and DATI and government organizations. Lots of venture capitalists are putting this in to sort of solve this problem of saying that how do we separate out the success of the organization and the success of the product. The cost of Dheeraj asks, the cost of Microsoft Azure and AWS. Well, you can go to their websites, but the interesting part is that at the basic level, these are designed to be free. So they're all designed for you to be able to try things out and see what you will need. And so if you're starting out with this, try certain free versions. Now, what that will mean is that may not give you enough input-output, and the data that it will probably allow is going to be small. You won't have millions of records that you can process. And there may be commercialization restrictions due to licenses. Those will need costs. obviously, but these are designed to have a free entry into the sandpit, so to speak. And so these are sandpits, and they're designed in order to allow easy entry into this field. All right. So common question on YouTube is, what is MVP? I absolutely apologize. MVP in the middle, to me, stands for two different things. I apologize. I should have made that much clearer. The first is minimum viable product. Minimum viable product. It is the simplest thing that does what it's supposed to do well. So it is quick, it does what it's supposed to do, and because it is minimal, it has the highest value, the lowest cost, etc. Minimum viable product. Second, sports fans, US sports fans, most valuable player or most valued player. It is the product that in some way is likely to be the star of what it is that you are doing, the MVP of your portfolio or the MVP of your ideas. So I joke a little bit on that second interpretation, but the first one is standard, minimum viable product. My error in not explaining that earlier. Minimal infrastructure requirements, Madhurao asks. It depends on what you're trying to do. If you're trying to build a prototype, not much. As I said, things can be deployed very quickly as SaaS solutions, software as a service solutions. If you want something that is on premises or something that's scalable, then you go into a more full-blown software development project, not unlike what a typical software development project would be. Thangarajan asks about sports. So the easiest answer to that is see the movie Moneyball, where you can see how data was used to identify who the good players are in a US baseball team. So that's one kind of thing. The other kinds of sports applications, for example, are in diet plans and things like that. Eric Stopol book on deep medicine talks about how do you create a diet plan that is compatible with your genetic makeup and what you want your body to be able to do. Many imaginations can be had out there. There are many questions coming in. We don't have as much time, so I apologize if I'm skipping a few. I talked about best practices on deployment, Sini. Kiran asks, use cases in power generation or IoT. Power generation, for example, clever uses of understanding the incipient failure of devices or residual life estimation. If you want good applications of that, maybe look at what GE is doing for Predix, and many other companies are. These applications are based on sensors, IoT-like sensors, the second part of your question, that essentially get data and say that this equipment is doing well, this is not due to this reason. Do you want to shut it down, or do you want to take the next time, sort of, timed downtime, so to speak, scheduled downtime, and then repair it and put it back into service? So linking forecasting, reliability analytics, this kind of condition-based maintenance is certainly one of the applications that has got many companies, GE is one, but Siemens, Philips, many companies very excited about this. Cloud environments, I talked about. As I said, you can start with, go to AWS. I didn't mention Google's cloud services, but certainly that's also a possibility as well. They all begin free. AI projects in neural networks. Neural networks, Ratnesh asks, neural networks are the base technology that goes into many of these language and vision products. CNN, convolutional neural networks for imaging, recurrent neural networks for text, but they're only one part of the full deployment. So it's necessary to know about them to the extent that what technology will be useful, but not to the extent that you need to be a neural network expert. What are the possibilities of AI in the manufacturing sector? Certainly robotics. Certainly robotics is a very important aspect to getting manufacturing smoothly done in Industry 4.0, but also other things. For example, quality control checks, inspections. Here's an interesting use case. So many of these things are about sort of detecting failures. Is a piece made properly? And you can take images and you can use supervised learning to see whether this is a crack, whether this is a defect, etc. More intelligent signals, for example, intelligent, sophisticated, like ultrasound, can go beneath the surface. And so quality control can be improved by doing image analysis on parts that are made. So there are many such interesting applications that are out there, manufacturing sectors. I talked a little bit about quantum computers. Possibilities for Indian Railways and the defense services. Certainly tracking, imaging, where is your train, so to speak, defense services, scanning, satellites, unending applications, many of which are certainly being used not only for Indian defense, but defense of other countries as well. Barriers to adoption.